So it'd be cool to let users provide rules or queries using Python syntax, right? But that's really unsafe. Tim Savage is the development lead for Westpac Databank, and he's going to show us how to do that in a way that's not terribly unsafe using the AST module. Please make Tim feel welcome.
Okay, this is going to be fun, just to start everything up. Please go full screen. Oh, now the screen. It's always the fun side, isn't it? Yeah, we're not going to get that going, are we? It worked when I tried it beforehand, but not now really. Yes, there we go. All right. So the standard advice in pretty much any scripting language is typically you should never use eval. I'm sure we've all heard that, whether we're doing Python or JavaScript or any other sort of a language of those types. So I'm going to go through some approaches you can use to make that safe and make that secure. So just to briefly introduce myself, my name's Tim Savage. I've been doing Python now about 15-something years. I currently work for Westpac, as I mentioned earlier, dealing with secure handling of data. And yeah, I'll reference some of that stuff that we've sort of used, some of these techniques in some of that work we've done. So I think I just wanted to briefly start before I get into exactly how to do all this stuff. There's just some use cases on why you'd want to do this, where it would be used. Even though I've been sort of dropped into the Django thing, this was originally a security talk, but some of this stuff will apply to things you might want to do in a Django application, especially APIs or using some of these techniques. So some of the use cases I'm going to go through here are within our platform, we use a lot of eventing when certain things occur, and we want to be able to trigger certain operations on those events, particularly notifications. Our operations team want to know when certain things happen. I'm not sure if anyone's ever worked in a bank environment. A release takes us about 4 weeks. So if someone wants a quick notification or a change made, a 4-week wait is often not very good. So we'd like a way to be able to then just to create their own sort of notifications, and that's one technique we can use. And then there's sort of the next one there, doing queries, expanding that into changing how that query operates, effectively creating a bit of a DSL kind of approach, which is something else we can do. So I think first up, I'm just going to run through some of the reasons why we're doing this and what can and can't happen. Again, the advice is not to do this, but there are some good and valid uses for eval. The standard library has a few. To call out one main example is named tuple uses eval internally. It sort of generates code, and then you eval it to actually produce your final named tuple object. So there are some good uses for it. But why is it dangerous? There's the interface does provide a couple of ways that you could probably think of making it safe. It accepts your globals and your local objects, so you can simplify that. But it also has all the built-ins are all there. Now you could go through and replace all those with nuns and what have you to try and keep that simple. Now, well, just to remove possibilities of executing import or print or open, of the various built-ins. But Python's meta, and we can do these kind of things. Now that doesn't technically use anything that's going to be in your globals or local variables there. So does anyone have any idea what that actually does? I'm sure there's some security people or Python people here that will dive into that stuff. Well, what this will actually do is print out every single type which is currently imported. So as you can probably imagine, if you can do that, you can instantiate anything. So we can have a look at a little example of this and what kind of nasty things could happen. If a user was to send this in via your API, for example, any ideas what that could possibly do? Well, the built-in quit is actually an instance of quitter. So that comes in, we've removed everything from our locals and globals, but as soon as it runs, boom, your application's gone. You know, it will quit the interpreter and you've effectively had your system DOSed. We obviously don't want that to happen. Now, I'll just call out some of these examples have come from Neil Batchelder's talk. If you want to know more about that, that's the place to have a look. I'm not going to go through complete details of all the nasty things of eval. He covers it very, very well there. So how can we safely execute that code so that we know that there's nothing dangerous in it? So I just want to get a quick sort of feel here of who's familiar with AST module, or who's heard of it, who knows it inside out. A few people. Who's never heard of it? There's probably a few here too. All right. So the AST module is in the standard library. So it's already there. It creates a syntax tree of any code you pass into it. It's used by all your favorite tools, PyTest and Black and Bandit and Co, which I do hope that you are using, or at least some of those tools, especially if you have code open to the internet. So yeah, let's have just a quick look at what a syntax tree looks like. So here's one where I've passed this fairly simple expression, object.x equals, double equals, 1, 2, 3. And we can see this has been formatted, sort of a tree of what that actually comes out to be. So we've got an expression. The body of that expression is a comparison. The left side is an attribute, and you can sort of see how it all comes down and loads out. Interestingly, if you want to know what Python is doing better, this is actually a really cool module to look at your code. See what's actually happening under the hood in Python. It might help you understand some of the behaviors that you see in Python. It's actually a really cool thing to look at. So that's what AST is. We have, within the AST, these are all sort of things that make up that tree. They're all, internally they're called nodes. We have literal variables, which are all your usual strings and integers and bools. There'll be variables. It'll be expressions, where we have your operators, comparisons, and subscripting and compressions, comprehensions. Statements, assignment, print, etc. And all this kind of stuff. So it can represent everything you can do in Python can be represented within an AST tree. So looking at that tree, we now need to sort of get an idea of what are we going to allow to be executed if someone's passed in some code. How are we going to check that and make it safe? Well, obviously, first thing is it's going to depend on your application. What are you trying to protect? What are you trying to allow? There's no one-size-fits-all here. Like any security, you're going to have to determine which parts or which pieces of code you're going to allow to be used. Some good examples here are you might only want to allow certain functions. So any and all, they could be useful within a particular context. You want to allow those, but obviously you don't want open. You don't want a user just be able to open up any file on their file system or import to bring in other things that could have other dangerous things. Obviously, removing all your dunder attributes can be a good idea as well. That would effectively neuter that example I put down at the start by not allowing them to just grab anything from your tree. So I've got a quick example of this, and obviously this is going to be some fun whether my code example is going to work. And it is. So I'm going to bring in some Vi first so we can actually have a look at this. And of course it's going to be tiny on the screen. So the AST module itself actually has a really good example of how to filter an expression straight away, if you look at the source code of it. And I've kind of cribbed that a little bit for this particular example, but expanded a little more to do a bit more useful things. So here what we've got is we've got this faked event, and I've got a little program here which will allow you to write expressions that will compare this event and see if it's going to match. And we're only going to allow it to do certain things. We don't want to leave open any possible function that you could execute within Python. So first up, we're going to allow comparisons. That's something that we'd like it to do. To do that, obviously, we're going to do a bit of recursion and pass in the left. Are we allowing that left node to come in? Check the comparators. So the comparators are where are the right side of your equation. You can actually have multiple, and that allows for the case of when you've got a whole bunch of things strung together. That can let you do that. We're going to allow any literal or constant. Those are fine. I'm going to limit what calls are available. So in our particular case here, you can use len to compare the length of something, but that's it. I'm also going to allow starts with and ends with attributes functions, so that you can use string dot starts with ends with to match certain things. And that's, obviously, and name. Name is so you can load any variable. That would be kind of useful. But we are going to filter that. We're only going to allow you to use names which are actually part of our event, because we're going to keep that kind of simple. We'll pull things out early on before we even get into our code. The rest of this is pretty boring, just functional stuff, so we won't bother with looking at that. But we will just run it. Okay, so we can type in any expression we'd like in here. So obviously a simple one, that's matched. So that's allows us to match it. So that's all being checked. That's an allowed expression. Similarly, we can use len. That's again matched. But if we come along and go, oh, okay, well, we're going to do a bit of it's going to say it's not found, so it's going to filter that out. So we've immediately prevented someone from starting to do something potentially nasty. Now, while we're only going to allow comparisons here, they're going to have to check that against something. It could be used to confirm that that particular user exists. So that's something we don't want to happen. So that's going to block it out. So back to eval. So we've validated the syntax. We know it's safe. What else? Well, we could say that's it. That's all we need to do. We're happy. We can now execute that code. It's not going to cause dangerous things to our application. But we can go a bit further than that. The AST tree can be edited. You can add things into that tree. You might want to put additional checks. A good example from the databank code base is we had to be able to define rules for matching different sets of data together. Now, we didn't really want to reinvent our own syntax for doing that. The original code was actually done in SQL, but we had some quite nasty things where we had to have 2 columns we had to be able to match them, but they were both addresses, and one contributor, well, one data set might have those inverted, so we needed to do sort of a cross thing. Now, Python has a really good way of doing that. We can have sets, we can do an intersection on them, if there's an intersection, but trying to write that in SQL is horrendous, and you don't often want to go into that. We also had a few other cases. So with Python, equality of two variables that have none in them is true, but that didn't really make sense in our application. Equality of two variables with none in them, we want that to be false because we don't want false positives. We're trying to find two matching entries here, and if they're both none, yeah, arguably they're matching, but in our context it's not. So we changed the behavior of equals in that case to give us the functionality that we needed. So you can define your own DSL. Another really cool use here is permissions. You might say, well, we have certain columns that we only want certain users to be able to do searching on. So you could apply permissions to certain things, and we can inject that all into our syntax tree. The other alternative, obviously, is just generating code. So if you can parse through a tree, you could extract the pieces out you want and generate code. So here's this example we were talking about before, I was just talking about then. We have that expression, but we want it to be slightly different. So we're just going to say if the left name is none, we'll consider that false. We don't want it to be considered a match. And similarly, putting in permissions. That's about all I have. I guess because I am in the Django comp, I will have to relate this back to Django in some ways. Obviously, security is multiple levels. So this will allow you to verify some syntax is correct. But there is still one caveat in that if someone just throws, if you put a couple of megabytes worth of deeply nested stuff into an AST, you're going to get a Stack Overflow, it's going to crash. You do want to filter input size. This is kind of outside the scope of this, but if you're doing web applications, that's something you do have to consider. Make sure you filter that size. Again, also verify who's putting that data in. You don't want to just allow anyone to put in anything. Make sure they're logged in, all the usual security layers. I think that's about all. I don't have any questions. Anyone want to do that?
All right. Thank you. Are there? Yeah. Applause. Thank you. Tim. Are there any questions in the audience?
Hi, thanks for the talk.
Cheers.
How easy is it using this AST stuff to actually 100% lock it down from anything that could go wrong? Like, my mind was going to things like, oh, what if we rebound methods to names that are allowed via our AST rules, things like that. Have you sort of tried to pen test your own security, I guess?
Yeah, so again, working from a bank, everything we had was pen tested. This went through pen testing. We got feedback from the pen testers that were making their job hard. So I was quite happy with that outcome. Like I said earlier on, it's going to be very dependent on your particular use case. There's no one size fits all. If you only want really simple expressions, then lock it right down to we're only going to allow this very basic stuff. If you've got more complex stuff, then yeah, you're going to have to do that. You're going to have to think outside the box and yeah, attempt to pen test it. Give it to someone else to try. Yeah, absolutely.
More questions?
Hi, thanks. Did you ever try to use the module to vet other languages? Like, for example, if you have embedded SQL, or is this something that you will only use for Python?
In this particular case, it is only really for Python. AST is obviously specifically for Python. There may be other modules around for checking SQL, but no, this is specifically for Python. For SQL, we did do other checking, and obviously your standard using parameterized queries for SQL is always a good idea.
All right. Let's come over there to the side.
Hi, thanks for the talk. We have a bunch of code that walks through ASTs.
Yep.
And something that we've been hit by multiple times in the past is when we upgrade, the version of Python we're actually running is accounting for the new node types in the grammar. Because the release notes typically don't have great underlying support for what the actual new underlying AST nodes are. Do you have any experience with upgrading Python versions and dealing with the AST library? And if you do you have any recommendations for how you can more easily do that upgrade process and account for all AST changes?
Yeah, we were kind of lucky in that we didn't actually go through any upgrades on this particular one. But in saying that, whitelisting is always going to be a good option here. I mean, the properties, or so the attributes that are available on each of those nodes are pretty locked down now. Obviously, when async and all those things came through, you do see some extra nodes for async. But if you've whitelisted them and saying these are the only ones we support, then any new ones, by default, they're not going to be allowed. So within up to you whether you want to allow those extra things or not. Yeah. Obviously, things like async could be a bit weird because then you have to. I've not actually tried evaling any asynchronous code, so yeah, that could be interesting.
Right, there was a question here.
Hi, you mentioned that you were using ASTs to do things like adjust the behavior of equals evaluations with nuns.
Yeah.
I was thinking, is there scope for, if you can lock out functions entirely, but say you wanted to allow the user to make variable assignments in a temporary namespace or something, can you modify the behavior of functions to limit it rather than just turn stuff off completely?
Yeah, you could actually completely replace things. I mean, one thing you could entirely do is that you could just parse that tree and generate completely different code. I mean, I did play around with an idea of converting a comprehension into a SQL query, which you could do. It could be a bit weird. You've still got the limitations of Python syntax. But yeah, I mean, there's anything you could really do on that.
All right. Another question somewhere? There in the back.
Yeah, first, just a comment on translating Python to SQL. There's a project called PyConAU. Oh no, I'm just more saying that there's, and there's a second question. Oh, okay. There's a second question of, have you thought about doing this at the bytecode level rather than the AST level?
We didn't really have a need for going down to the bytecode level. I haven't looked at that. No, it was mainly at the AST level. Yeah, AST was just convenient for doing these kind of things, and the kind of stuff we were doing, it kind of fit into that model. Cool.
All right. Another question. You have another 5 minutes, so get your question ready.
Sorry, it's not the question. It's more like a comment. So we're also using a.
Please
Huh?
Please ask a question in a form of why, where, how.
Okay, sorry.
Time outside.
Yeah.
Okay. Thank you.
Thanks, Tim. I saw you trapping the syntax error.
Yes.
If there is a syntax error there, do you get anything from the AST parser? Do you get half a thing that you can then work with to give feedback to the user?
It would probably depend where we were trapping that. I mean, if we were trapping that at the AST level, I don't think you do. I think you've lost that. Obviously, the syntax, I mean, you will get things like the line number or the offset, and you get all those usual things that Python provides. And we did try to modify that and provide that back to user because obviously we want to make it friendly to them. It's the people who are using this in our particular case were operations, not particularly Python developers, so we wanted to make that as easy as possible. And so there has been those usual comments that some of Python's errors aren't that obvious in some cases. So we did try and enhance those a little bit for our use case.
There was a question in the back here.
Hi, so you mentioned the release process takes around 4 weeks. I wonder, how do you tackle when you mentioned that the new Python version comes out and it's possible that you get an expression supplied which your current validator does not support, that it will throw an error, let's say when the async was introduced?
Well, our releases are of a Docker image, so a new release of Python wouldn't really affect us because we would release a new, whole new Docker image with whatever Python that we particularly use. So yeah, we are kind of protected from that. Again, bank environments, they're not going to do major releases of software or even point releases like that without thorough testing before it gets anywhere near it.
All right, more questions. 2 minutes left.
Hi, thanks for the talk. You mentioned if you throw a deeply recursive function at it, it will blow up.
Yes.
I presume, does it just give a fairly standard recursive exception that you can catch and throw back to the user in a normal way? It doesn't blow up too deep?
I haven't actually tried going too far to blow that up. This was the warning in the AST module itself. So the AST docs have that great big thing here saying, don't put deeply nested things in here, it could have bad side effects. And again, that's why I sort of mentioned, if you're putting this on a website, please limit the size that going into that. That's sort of expected behavior anyway. But I'm not 100% certain on that. It may give you a recursion error, it may just crash. We probably want to avoid that later situation.
All right, 1 more minute.
There is a library. It's called Simple Eval. Did you see this library? Did you look into this library? So it uses the same idea, but it just gives you something. Yeah. Okay.
All right, then we have a token of appreciation for Tim. Thank you.